We're going to define a few important terms that relate actually to many types of waves, most types of waves, if not all. But we're going to talk about them mainly in light because it's where you see the most examples. So one is transmission, and we'll come back to this picture as well in the end and talk about where we see transmission, reflection, absorption, and some diffraction. So let's just define them out, and then we'll look at them individually. So transmission is when light goes through an object. It transmits through the object. The energy is transferred to the object and then re-released on the other side. This is why the inside of your car can get pretty warm, is because the energy from the sun is transmitting through the glass in your car to the inside. Reflection is when light hits and bounces off an object. So a mirror. We talked about a bunch of these, right? Transmission's also lenses. So lenses transmit light. Mirrors reflect light. This can cause a mirror image. No energy is gained or lost here. It's just simply bounced right off. Then we have absorption. Absorption is when light hits an object and transfers the energy to that object. So absorption, you're literally taking the energy of the wave and you're absorbing all of it. You're gaining all of that energy yourself. The last one is diffraction. Diffraction is whenever light bends around a barrier. So if you've ever noticed, if you're really close to a wall, your shadow is very distinct. There's a very sharp edge to it. But as you get further and further away, your shadow will start becoming more and more blurry on the edges. That's because of diffraction. So the first is some pictures of transmission. So here's a leaf, and the leaves are thin enough where the sunlight can actually go through them, and so the light is being transmitted through the leaf. This is where you come into tint jobs. So whenever your tinting says that it's a 40% tint, it's telling you how much sunlight will actually go through. For regular clear glass, 100% of sunlight starting, only 80% is able to get through that glass. But then if you have a certain level of tint, if you have a 40 tint, then only 40% of the light will actually make it through. There's special kind of glasses as well. So some skyscrapers, some newer buildings and colleges are built with a special type of glass, which is called R20, where the sunlight, instead of 80% coming through, has certain films on it where very little sunlight actually is able to get through. So this also helps reduce the amount of energy in the building, so it keeps it cooler, so you don't have to run the air conditioner as much and things like that. Reflection. So this should look familiar. The law of reflection, where the angle of incidence equals the angle of reflection. But notice it doesn't matter if it's a smooth surface or a rough surface. Reflection is still equal on each side. This will give you a perfect mirrored image where you can see yourself really clearly. A rough surface is where you can kind of see that there's a slight image, that you can tell that there's something there, but you can't see any distinct lines at all. But you should notice that, again, it comes in and reflects at the same angle. It comes in, reflects at the same angle. Comes in, reflects at the same angle. But this is why it's a blurred image, a blurred reflection, whereas this one is a perfect mirrored reflection. The next one is absorption. So here is an incident light. So this is red, green, and blue light. If you have a red filter, then it's going to absorb the green and absorb the blue. The reason why it appears red is because it only allows red to go through. So green and blue are absorbed. Here's just a diagram showing all three of what we just talked about. So reflected means it bounces perfectly off. So no energy gained. Transmission is where the energy is just moved from one side to the other. That's your glass. And then, of course, absorbed. Here, the energy stays within the object. The last one is diffraction. This is what causes the blurring of your shadows. So if you have, say, waves, if you've ever seen water waves will do this too. When the waves go through a barrier, they start to bend outward. So just like here, they come in and then they start to bend outward. And this will cause this kind of arced pattern, which is what causes that blurring. So the last thing I wanted to talk about is the wave-particle duality. So this is saying that light behaves as both a wave and a particle. So diffraction, up here, diffraction is a property that only happens with waves. If it was a particle, then whenever it hits this barrier, then whatever is here would just go in a straight line. You wouldn't see any of this arcing happen at all, just be a straight line. The photoelectric effect is only a particle. So photoelectric effect is basically whenever light hits an object, hits a certain type of metal, it will release electrons in the form of energy instantly. And that only happens if light acts as a particle. Now, diffraction, reflection, things like that can happen for both waves and particles. So these two are the ones where we can tell that light is a wave and a particle. It's both.